Hey guys, today we're going to look at the perfect square trinomial. It may or may not be a review for you, but we're just going to go through it, see what happens. So if we have a trinomial in the form ax squared plus bx plus c, it's a perfect square trinomial if the b over 2, cut b in half, and squared is equal to a times c. Now, to make it usable, we usually factor out the a first. So that would just mean b over 2 squared would equal c. We'll see that in a minute. But if we look, 8, divide that by 2 is 4. 4 squared is 16. So this is a perfect square trinomial. So it'll factor as x plus b over 2 is 4 squared. So the sign comes from the sign of b. The number here comes from b over 2. Let's test that out. If we use the distributive property, we can check and see that we get the same thing back. Remember, squaring something means multiply by itself. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Combine like terms, and we do get the original back. X squared plus 8x plus 16. So you can see that this is the same as this right here. It's factored form. So we're just going to go through and factor these. Let's see. If we cut 18 in half, we get 9. 9 squared is 81. This is a 1. These are all 1s. That's nice. So we're good. So it's going to factor m, because that's our variable. Whatever sign is here, half of this squared. Now that only works because this is 81. This is b over 2 squared. If it's not, we're going to have to fix it. 2 over 2 is 1. 1 squared is 1. We're good. We can factor this. 10 over 2 is 5. 5 squared is 25. We can factor this. So these are all perfect square trinomials. And that's how you factor them. Now we're going to use that, but we're going to actually complete the square so we can convert from standard form to vertex form. Now, if you're a person that likes steps, I wrote out some steps for you. So we start with ax squared plus bx plus c. Those are all caps. First thing we do, separate out that c. Get it out of there. Then we factor out a, whatever it may be. If it's 1, we don't have to factor out anything. If it's not 1, factor it out. And we get a times x squared plus, notice that's a little b, that's not a typo, x plus c. And I just made little b equal b over a, whatever that is. If a is 1, it's little b is big B, doesn't matter. Now this will be a lot clearer whenever we start doing them in the next slide. Then we got to figure out what c is, what little c is. Now remember, for completing the square, we need b over 2 squared to be c. So that's what we need to do. And then we're going to add c on the inside. So inside of the parentheses, we add little c. And if we think about it, if we use the distributive property, that's a times c. So we need to subtract a times c on the outside. That way it's the same. Whatever we added in here, we're subtracting out here, makes 0, not changing anything. And you just simplify it and factor it. So let's look at some examples. So here we go. First thing I'm going to do, get my c out of the way. And then I'll just put that plus 4 out here. Now, a is 1. So if I factor out a 1, it's the same thing. Not going to change anything. So let's look at our steps. A here is 1. So don't need to do anything here. So now we need to figure out what c is. It's b over 2 squared. B is 4. So I'm going to figure that out. So 4 over 2, I'm going to square that. That's 2 squared is 4. Oh, hey, that was already a perfect square trinomial, huh? So x squared plus 4x. I'm going to add the 4 that I just calculated on the inside, plus this 4 right here. And I'm going to subtract, well, it's a 1 right here, so 1 times 4 is 4. Well, hey, not going to change much in there, am I? So if I do that, I now have a perfect square trinomial. Yeah, it was already. So we know how that factors. It's going to factor as x, this sign, half of this, squared. 1 is our a. And then a plus 4 and a minus 4, that's nothing, that's 0. So that's it, done, factored. And now it's in vertex form. So we can write f of x equals if we want. So now we can see that our vertex is -2, 0. We can see that our a is still going to be 1, same thing our a was here. So we could plot our vertex and graph this parabola. Let's try the next one. So if you want to, you can test and see if it's a perfect square before you do it. 8 divided by 2 is 4, 4 squared is 16, not the same here. So separate out that c. X squared minus 8x plus 18 over here out of the way. Then I'm going to do b over 2 squared. -4 squared is 16. So I'm going to add that on the inside. X squared minus 8, oops, 8x plus 16. I have to subtract whatever this is, which is 1, times that 16 on the outside. So I didn't miss the 18. I need to subtract 16. So right now these parentheses really aren't doing anything because we don't have an a. So if I were to just simplify this right now, I'd have the 16s cancel, right? So I'm not actually changing anything in this equation. I'm just changing how it looks. But since we did this, I can now factor this as a perfect square. X minus half of 8 is 4 squared. 18 minus 16 is 2. And that's our function in vertex form. All right, so we know our vertex would be 4, 2. Our a is still 1. Ah, here we go, something that has an a that's not 1. Let's do it. -x squared plus 6x. Isolate that little constant over there. Get out the way. Figure out what c is. Cut b in half and square it. Gives me 6 divided by 2 is 3. 3 squared is 9. Oops, what did I do? Remember, we got to factor out a. Look at that. A is not 1 in this case. So that's where the difference is. People, before you do anything else, make sure you factor out a. So I'm going to factor out this -1. So -1. Get out of there. X squared, and if I take it out of a positive 6x divided by -1 is -6x. Just factored out that negative. Anytime you have anything that's not 1 right here, just factor it out. Then you can figure out what c is. So -6 over 2 squared. That's still going to be 9. So I didn't change what it was because that was just a -1. On the next one, though, that'll change it. So I'm going to add this on the inside. Don't forget that negative out there. Minus 5. And then I'm going to subtract this times what we just had, negative 9 on the outside. So I'm subtracting negative 9. Okay. Negative x squared. Oh. X, sorry. Need to factor it now. X minus b over 2 is 3 squared. That's a negative 5, and a positive 9 makes a positive 4. There we go. Our vertex is positive 3, 4, and our A is negative 1, so that's going to flip it upside down. Okay. Let's look at this one. So again, separate that constant. Don't forget, factor out A. If it's not 1, you got to factor it out. If it is 1, it doesn't make a difference. So 2 times. If I take a 2 out of here, I'm left with x squared. If I factor out a 2 from here, I'm left with a minus 6x. It's just the reverse of the distributive property, guys. 2 times negative 6 is negative 12x. We factored out, we're dividing. After we factor it out, then we find out what b is. Look, if I were to try to do it here, I'd have done 12 divided by 2 is 6. 6 squared is 36. However, we can't do that because our b, our little b, is actually 6, negative 6. Over 2 squared, that's 3 squared is 9. Okay? So that's what our little c is. X squared minus 6x. Remember, add that on the inside. And then we're going to subtract a times our little c. That's 18 on the outside. 2 times 9 is 18. Then we can factor this. Let's get the 2. X minus half of 6 is 3 squared. 13 minus 18, that's negative 5. And there we go. So on this one, our vertex would be 3, negative 5. It would be pointing up, and it would be skinnier. Vertical stretch of 2. So yeah, I think we've got a few more we'll try. In this case, we don't have a C. Who cares? Doesn't make a difference at all. So I'm going to group it. Yeah, there's nothing much to do there. It's just stuck some parentheses around it because there's no constant here. Now I need to figure out what little c is. That's b over 2 squared. Oh, no, not fractions. Yes, fractions. So if you have a nice calculator, you can just type it in there. Let me try this. I'm not sure if it's going to square it properly or not. It does. Okay. Or if you don't have a nice calculator like this, just square your numerator. 25, that's the numerator. And square your denominator. 4, so 25 over 4. No decimals, people. Decimals are not allowed. So this is what we're going to add on the inside and subtract on the outside. 25 over 4 on the inside. And then we're going to subtract. Well, a is just 1, so that's nice. 25 over 4 on the outside. After that, we need to factor it. So that's going to be x plus 5 over 2 squared minus 25 over 4. And there's our vertex form. So our vertex would be negative 5 halves and then negative 25 fourths. Okay. So yes, it's possible to deal with fractions, just deal with fractions. All right. Let's look at another. A little bigger. Okay, so separate, oh wait, there's nothing to separate out. There's no constant here. Factor out, factor out a. Figure out what little c is. Add that on the inside. Subtract a times that on the outside. Factor it. B over 2 is 1. There we go. Vertex is 1, negative 4. All right. Yeah, why not? A couple more examples. More examples never hurt. Here we go. First thing we do is isolate this constant. Factor out a. $20 divided by negative 2 is negative 10. Then figure out what little c is. All right, we're going to add that on the inside. On the outside, we're going to subtract a times this. Negative 2 times 25 is negative 50. So we're subtracting negative 50. We factor combined like terms simplify. Squared, that's plus, and there we go, we're in vertex form. Okay. And yeah, you could write f of x, but I got lazy. Here we go. Separate out the constant. Factor out a. So this is going to be a little interesting. So you guys hate fractions. Whatever that is, you got to factor it out. To factor out, you divide. So if you don't remember to divide by a fraction, you reciprocate and multiply. You can just type it in here. Negative 4 divided by negative half. Which is 8. Always check yourself. If I were to distribute this, -0.5 times 8 is -4. So we're good. Those better match up. This times this better be that. Now we can figure out what little b is. 8/2 squared, that's 4 squared is 16. Add the 16 on the inside. I'm going to subtract this times this. -0.5 times 16 is -8 on the outside. Factor, combine like terms, simplify, all that good stuff. Half of 8 is 4. Oops, yeah, there we go. Squared. -5 plus 8 is 3. The end. Okay, guys, all that leads to graphing. So, of course, you could graph this one in standard form, but we're not gonna. We're gonna do it in vertex form. So we're gonna rewrite this in vertex form and then graph it. It does make it a little more convenient to graph, but the main thing is whenever we talk about other conic sections, that's where we're really gonna need this. Okay, so separate it. Factor out on A is 1, keep going, find out what little b is. If you're getting a negative whenever you're doing this, use parentheses. If you don't use parentheses, you're gonna mess everything up. Use parentheses, people. So I added 36 on the inside. That's 1 times 36, so that's subtracting 36 on the outside. Factor that nicely. X minus 6 squared plus 39 minus 36 is 3. And there we go. My vertex, 6, 3. Axis of symmetry is x equals 6. A is 1, so I just use 1, 3, 5. Don't even have to look at it. Domain's all real numbers because it's quadratic. It's a polynomial. Domain's all real numbers. Plot your vertex. 6, 3. Go right one up. A times the odds. And there we go. Our range, well, I guess I'm going to finish graphing this. I'm going to try and make a nice round bottom on these. -infinity to 3, that's my range, right? No. It's 3 to infinity, people. 3. And that is a solid dot right there, so we are including 3. All right, guys, that's it for completing the squares. Go rewatch this video about 20 times, and you might get it. See ya.